Welcome to this tutorial where I'll be going through organic chemistry equations that ECZ has brought in the recent years. It says, the first question says, name the organic compounds with a structural formula shown below. Okay. Even before we get to answer the question, let us revise a few examples of organic compounds that we have in the ECZ syllabus, starting with alkanes. Remember, the definition of alkanes is that these are hydrocarbons that have single carbon to carbon bonds. Okay, so what I mean is this: the bonds between carbon atoms is single. Okay, so all organic compounds having single carbon to carbon bonds are called alkanes. Okay, that's why alkanes are mostly regarded to be unreactive because they do not contain what we call a functional group. Okay, a functional group. Okay, meaning that there is no position where atoms can attach during a chemical reaction. So there is no bond that can be breaking and other stuff. Alright. Then for alkenes, they defined as organic compounds having double carbon to carbon bonds. So the bonds between carbon atoms are double. Okay, and the functional group of alkenes is what we call a double bond. A double bond. Remember, the definition of a functional group is just it's a group of atoms or an atom that represent the properties of an element of an organic compound. Okay, so like they help us to identify a specific organic compounds. So for alkenes, once you see the presence of double bonds, then that compound is an alkene. For alcohols, their functional group is this hydroxide, it's a OH. So any organic compound that is attached to this OH here is an alcohol. Okay. Then for carboxylic acids, their functional group is this part here, the one that I have circled. Okay, this part here. It's called a carboxyl functional group. Okay, carboxyl functional group. So any organic compound with this functional group that I have circled is likely to be a carboxylic acid. Then for esters, remember esters are formed from a reaction of an alcohol and an acid. Okay, so their functional group would look like something like this. Okay, so we'll have that and that. So it would look like something like this. Okay, so here we have our carbon chain. Alright, okay. So just this part. So it's just observe this part here. Once you see this part here, then that organic compound is likely to be an ester. With this understanding, let us attempt to answer the given question. One, since like it has this hydroxide functional group, it belongs to a class of organic compounds called alcohols. And this alcohol, since it has one, two, three carbon atoms, starts with the prefix prop. Okay, it starts with a prefix prop. So in writing the name of this alcohol, it will be prop. It will be propan. Okay, allow me to erase this. Okay, then now we consider the position of this hydroxide functional group. As we can observe, it is attached to the first carbon atom, so its name will be propan 1 and ending with O, since alcohols end with O. So the name now becomes propan 1O, like that. Okay, let's get to answer the second one. Okay, so as we can clearly observe the functional group, it belongs to a class of organic compounds called carboxylic acid. Okay, and the name of, the prefix of this carboxylic acid, since it has 2 carbon atoms, is eth. So it will start with eth. Okay, so its name will now be, let me erase this. Its name will now be ethanoic acid. Its name will be ethanoic acid. Okay, all right. Then number three here, this organic compound is actually a polymer. Remember, a polymer is an organic compound that is made up of many repeating units called monomers. So as we can observe here, we have these repeating units here, and the name of this repeating unit, or rather the name of this monomer, is called vinyl chloride. Okay, vinyl chloride. Okay, and the name of this entire polymer is what we call polyvinyl chloride. Vinyl chloride. Okay, or simply PVC. Alright. The second one says a hydrocarbon belonging to the alkane family has the molecular formula that, where X is the number of hydrogen atoms in one molecule of the hydrocarbon. State the general formula of the alkanes. So the general formula of alkanes is like this: SC, this is subscript N, like this, plus 2. Okay, so this is a general formula of all alkanes. The number 2 says use the general formula to find the value of X in C4H6 and state the name of the hydrocarbon. Okay, so we have established to say this is the general formula of alkanes. So in finding the value of X, we should just remember that this N here represents the number of carbon atoms. So this will now be, so like I'll say H2. Okay, let me not even include the H. Okay, so just say 2 open brackets, let me substitute 4 here, plus 2. So this is giving me a value of 10. Thus X is equal to 10. Alright, and now, okay, now let me write the full chemical formula of this organic compound. Let me quickly erase this. Okay. So its formula will be C4H10. And remember, the hydrocarbon that has 4 carbon atoms is called butane. Okay. Then the third one says draw the structures of the 2 isomers of the above hydrocarbon. Okay, let's underline some key terms that we have in this question. So we have term number 1, isomers, and term number 2, hydrocarbon. Remember, a hydrocarbon is just basically an organic compound that has hydrogen and carbon atoms only. So examples in our syllabus are just alkanes and alkenes. Those are the hydrocarbons that we have. Okay, and isomers, remember, these are organic compounds that have similar chemical formula but different structural formula. So we are told to write the isomers of this organic compound that we named in question B2. Okay, we established to say that its name is butane, like that. Okay, right. We should remember that butane has 2 isomers. The first isomer of butane looks something like this. So like this. Then the hydrogen atoms like that. Right. So the name of this isomer here, it's called normal butane. Okay, like this. Just write normal butane. And the other isomer of butane looks something like this. Let me erase this. So it looks something like this. And the way you name this isomer is by following what we call UPAC nomenclature rules. Okay. And the first rule that we should recognize is that we should identify the longest carbon chain and name it. So as we can observe, okay, let me change the color. As we can observe here, the longest carbon chain has 3 carbon atoms. It's like this. Okay, so it and the hydrocarbon with 3 carbon atoms starts with prop. Okay, so let me just write this on this separate part here. Okay, then number 2, we should identify the branches, or rather the subsequence. So as we can observe here, the subsequent of this long chain here, it's on carbon number 2. Let's count 1, 2. As we can observe here, the branch is on this carbon number 2, so it will be 2. Okay, and this CH3 is a methyl. Okay, so it will be 2 methyl propane. Propane, sorry. Okay, 2 methyl propane, like that. So this is the name of the 2 isomers of butane.